Okay. Can you see the screen? Hello? No? I have shared the screen. Entire screen. Yeah. Okay. Right. So, last lecture, we have seen what is hypothesis. Okay. And different terms that are related to hypothesis. What are different types of hypothesis like null and alternative hypothesis? What is p value? What is degree of freedom? What is confidence interval, significance level? All that we studied in last lecture. Okay, so this lecture we will talk about what is hypothesis testing and what do you mean by parametric and non-parametric tests. Okay, so see, there are two types of tests. One is called as parametric test and another is called as non-parametric test. Okay, now what is the difference between parametric and non-parametric test is that in the parametric test it majorly and it basically relies on the statistical distribution in the data. Okay, so whereas you have the observations and there is a frequency associated with that observation, so some uh, some variables are defined and for those variables different observations are there. Okay, so such type of statistical distribution or that data is necessary to perform the parametric test, whereas when we talk about non parametric test it does not depend on any type of distribution. Like you in non parametric does not make any assumptions and measures the mean, median, central tendency means what? Mean, median, mode. Okay, these are nothing but called as central tendencies. Okay, so in non parametric test you do not make any assumptions, whereas in parametric you may make certain assumptions related to your data or related to your study. Okay, so some examples of non parametric test, just a moment. So some of the examples of non-parametric test, these are like Man-Whitney test, Kruskal-Wallis test, etc. Okay, these are nothing but non-parametric test. So when we talking about a parametric test, it is actually the statistical test which makes certain assumptions related to your data or related to the parameters that are involved in the data. Okay, and the distribution about the population is known. Like suppose how many observations are there, what is the frequency of that observations, and different characteristics of the distribution you can easily find out in the parametric test. So it uses the mean value like mean, median, mode. All these different types of measures of central tendencies can be used in parametric. So that is the main difference between the parametric and non-parametric test. This we have already discussed. Okay, what is p value? So p value, p is nothing but it stands for the probability value. Okay, so it is a value of probability of obtaining the result of statistical hypothesis test, and it assumes that the null hypothesis is correct. So p value, it it is should be less than the your significance level. Okay, and then we have the degree of freedom. So degree of freedom is defined as n minus 1. So n is nothing but number of observations or the number of what we can say data occurrences, that is nothing but called as n. So total observations under study, and n minus 1 is nothing but, suppose your total observation is 100, then The degree of freedom is 100 minus 1, that is 99. So so uh, degree of freedom, we can define it as the number of observations in the data that are free to vary when estimating statistical parameters. Okay, so that much variation is allowed. Okay, that is defined by the degree of freedom. Then there is something called as significance level. So significance level is nothing but called as alpha, and then there is something called as confidence interval. So significance level, that is alpha. How do you get alpha? Subtract your confidence level, that is 0.95, that is your confidence level, okay, from 1. That means there are chances that the 95% of the data is accurate. Okay, yeah, and only 0.05% variation is, there are chances of 0.05%, 0.05 level of variation, right? So if you want to be 95% confident that your analysis is correct, then alpha would be 1 minus 0.95, that is 5%. Okay, so this is how you calculate significance level and confidence interval. Now we will look into some of the tests. Okay, now there is a very simple test that we are going to see today, that is called as t test. Okay, so t test, it is nothing but comparing the group means. Okay, comparing the group means. Suppose there can be single group, or there can be two groups, okay, involved in the study. So it is one of the common test that is used in the statistics. And the t test, what is the use of t test? It is used to determine whether the means of two groups are equal to each other or not. Okay, that is uh, that is defined, and that is why the t test is used. म्हणजे दोन ग्रुप जे आहेत तुमच्या स्टडीमध्ये, समजा दोन ग्रुप्स असतील, तर त्या दोन ग्रुप्स मध्ये, okay, whether the means of the both groups are same or not, okay, that you can verify, and that you can calculate using the t test. Okay, now under t test there are different types of tests. Okay, first is one sample t test, then two sample t test, and then paired t test. Okay, these are three types of t test. Now one sample t test, what is one sample t test? It compares the sample mean with the known value. So there is only one sample that is involved in the study. Like suppose there is one variable, say for example x. Okay, and for that x variable you conduct one sample t test. So compare the sample mean with the known value when the variance of the population is known. So that sample is drawn from the population, and in this case we assume that the variance, see there is a standard deviation, and then there is something called as variance. Okay, so in this case, the variance of the population which is involved in the study is unknown. Okay, it is not known, and then you try to compare the sample mean with some set value or some known value. Okay, that is the purpose of one sample t test. Then there is another test that is called as two sample t test. In sample t test, what happens? It compares the means of two groups under the assumption that both samples are random, both samples are independent, and they are normally distributed with unknown, but both samples have equal variances. Okay, variances are equal, and there are two samples that are involved in study, like x and y. So there has to be two numeric vectors you have to define while carrying out this two sample t test. And then we have the paired t test also. So paired t test, it compares the means of two sets of paired samples taken from two population with unknown variances. So we are going to see the example of each of the type of test. Okay, so first is t test using R. Okay, so the function that you use for performing the t-test is t.test function, and this can be used to perform both one and two sample t-test on the vectors of the data. So you have to define the numeric vector. Okay, so let's say you define the vector x, and then you take this vector x as an input for performing the t-test. Okay, we know how to define the vector. Now here is the syntax to perform the t-test. Okay, so t dot test in bracket x comma y is equal to null. So first I will read this, what we can say, the instruction, and then I will tell you what is the meaning of each term. So t dot test in bracket x comma y is equal to null, then mu is equal to 0, then paired is equal to false, then var, that stands for variance dot equal is equal to false, and confidence level conf dot l level, okay, is equal to 0.95. So these are the input parameters. These are nothing but called as, whatever we have defined in the bracket, these are called as the arguments that we are passing to the function t dot test. Okay, so here x is the numeric vector of the data involved, and now in this case, since it is one sample t test, that is why the variable y we have defined as null. Okay, y is equal to null means what? Yes, y is equal to null means it is a empty vector. Yes, it does not have any value, not even 0. Okay, so there is only one vector, that is x. So where x is a numeric vector of data values and y is what? Y is an optional numeric vector. So whenever we will be performing two sample test, in that case we will pass both the parameters x as well as y. But since we are now performing one sample t test, we have taken x as an input and y we have defined as null. Got it? Yes. Hello. Yeah. Just a moment. I'll see who is. I thought someone was trying to join the meeting. Okay, so we have excluded y. So if y is excluded, the function performs one sample t-test on the data that is contained in variable x. Okay, and whenever we include y also, it is called as two sample t-test. Now what is mu? Okay, mu argument is nothing but it stands for mean, okay, or average. So mu argument, it provides the number that indicates the value of mean, okay, the average value. Now in this case we have defined mu as 0. Okay, but you can define, or whatever, in the research question you may come across, or you can calculate the value of average, and then you can use that average for calculating the t-test. Okay, so mu is equal to 0 now in this case. Okay, then yes, then by default, just a moment. Yeah, so by default the test perform the two-sided t-test. Okay, two-sided means we have seen the normal curve. Yes, we have seen a left side as well as right side normal curve, the bell shaped curve. I, if you remember, I drawn that bell shaped curve last time. Yes, acceptance region, rejection region, I explained. Yes, so when it is, when the tail is extended to both the sides of that normal curve, okay, that is called as two sided. Okay, so this t test, it by default it performs the two sided t test. So both regions it shows positive side as well as right, right side as well as left side. Okay, so the paired argument, there is something called as one of the argument that is called as paired. Okay, so paired is equal to false. So what is paired is equal to false? The paired argument, it will indicate whether or not you want, excuse me, whether or not you want paired t-test. Okay, so when your paired is equal to false, that means you are certainly not performing pair t-test. And when paired is equal to true, that means you are performing paired t-test. And when it is false, you are not performing pair t-test. Okay, so that is what is the significance of argument paired is equal to true or false. Then the next argument is var dot equal is equal to false. Now var dot equal is, it stands for variance. Okay, or variance, whatever you pronounce. So variance dot equal argument, it indicates whether or not to assume the equal variances or variances when performing two sample t-test. So when there are two samples which are involved in the study like x and y, so then you can assume, you can make certain assumptions whether the variances of the two samples, whether they are equal or whether they are not equal. So if the variances of equal, they are same, then you can say true. Yes, the argument you can pass the value as true, and if the variances are not same, then you can pass on the value as false. So variances dot equal is equal to false, or variances dot equals is equal to true. Okay, that is the argument through which you can assume the variance as same or different. Okay, then the next argument is confidence level. So confidence dot confidence dot level is equal to 0.95. Okay, so confidence level argument, it determines the confidence level of the reported confidence interval. Okay, for maybe whether it is a one sample t test or whether it is a two sample t test. So whether your confidence level is 0.95, that is 95%, or it can be 97%, or it can be 90%, depending on what, how much accuracy, okay, you want in your data, and it also depend on the accuracy of the test. Okay, so confidence level, we normally, the researchers, they define the confidence level as 95%, right? So that is how we write the syntax of t-test. Okay, now here is the example. Okay, so let's say x is the numeric vector. Okay, and y is one more numeric vector, right? So then first what we are doing is, first we are calculating the mean. Okay, so simply we execute the command mean, in bracket you pass on the variable that is x. So it will give you the mean of the numeric vector, that is in this case 42.9, let's say. Okay, then you write the t-test command. Okay, so x comma y is equal to null, because we are, let's say, performing one sample t-test. So y in this case is null, and then mu. So mu in this case, since we have calculated, we have taken 42.9 as a mean. Okay, so mu is nothing but the mean or average, so which is nothing but 42.9. And then variance dot equal, so it is false. Okay, that variances of the because since there are not two samples in this case, so we have defined variance dot equal is equal to false. Yes. Okay, so whenever you execute this command, you get the result like this. Okay, in R. So it will first will display what is the test that you have conducted. So it will display in the result the name of the test, that is one sample t test. Okay, then what is the input data? So input data is nothing but the numeric vector x. Okay, which we have already defined. Yes, this is the numeric vector 45, 50, 34, like that till 50. So data input is x. Okay, then it will give certain values. Okay, so value of t t value is equal to 0. So t value is nothing but the table value. Generally whenever we are calculating this, since it is we have executed this in a software like our software, but generally whenever we perform or try to solve this t-test numerical manually, then there are certain log tables which you have to refer, like you have to observe the values in that log table, and then you have to note down the values. So there is a t table, there is a f test table, like that there is a z table through which you have to observe the values, and then you have to note down the readings. So in this case, the t value is 0, then df is degree of freedom. Okay, what is degree of freedom? Here degree of freedom is 9. Why 9? Because degree of freedom is nothing but n minus 1. Okay, now what is n? N is nothing but number of observations. So in this variable x, how many observations are there? 10. 10 observations. So n minus 1 is nothing but what? 10 minus 1, that is 9. So here degree of freedom is 9. Okay, and then it is giving the result that p value is equal to 1. Okay, p value is equal to 1. So p value is nothing but the probability value. Okay, depending on the p value, okay, you compare the p value with your significance level. So significance level in this case is 0.05. Okay, because the confidence interval is 0.95 and your significance level is 0.05. So you always compare your p value with the significance level, that is 0.05 in this case. Okay, and if the p value is less than 0.5, then we reject the null hypothesis. Now in this case, the p value is greater than 0.05, because what is the value that we are getting? P value is equal to 1. So 1 is greater than, yes, can you see this yellow highlighted text? P value is greater than 0.05. Hence, we fail to reject H O. So H0 or H naught, that is nothing but null hypothesis. So in this case, since p value is greater than 0.05, we fail to reject null hypothesis. In short, we say that we accept the null hypothesis. We fail to reject null hypothesis means we are accepting the null hypothesis and we are rejecting the alternate hypothesis. This is how we interpret the result of the test. Okay, so alternate hypothesis is that true mean is not equal to 42.9. See, we are comparing the mean. This is through t-test. What do? We compare the mean. So here the alternate hypothesis, it states that the true mean is, it is not equal to 42.9, whereas the null hypothesis, it states that the true mean is equal to 42.9. Okay, yeah. So there is 95% of the confidence interval. Okay, and then this is nothing but the lower limit, this is nothing but the upper limit. Okay, so 37.80 and 47.99, and then the sample estimate, that is the mean of x we have taken, that is 42.9. So p value, since it is 1 and 1 is greater than the significance level, that is 0.05, hence we fail to reject the null hypothesis. Okay, that means we are accepting the null hypothesis, and null hypothesis is that the mean is equal to 42.9, which is true. Okay, so let us perform this test in using R. Okay, I don't know, my computer, this PC is getting slower. I have downloaded many things, software. So this, it has, sometimes it is hanging. Sometimes it is taking too much time to open the application. Yes, right. So let's see. I'll just copy paste this vector x. Okay, this is the vector s that we have defined, right? Similarly, we will define vector y. Okay, so let us say vector y I have defined here, right? So both vectors we have defined. Now we will calculate mean. So mean in bracket x. Okay, it is giving us the mean value, that is 42.9, right? Now what we will do is we will write the code for t-test. Okay, so it is t dot test in bracket x comma y is equal to null, right? Then mu is equal to the value of the mean, that is 42.9 we have just calculated, right? And then variance dot equal is equal to false, right? Now we will execute. Okay, just press enter. So now it is giving me the result like this. So it is one sample t-test, data, t-value, degree of freedom, p-value. Then it will state the alternative hypothesis, 95% confidence interval. So interval is, what is the interval? The interval is this, between 37.80 and 47.99. And then this is the sample estimate of x. Similarly, we can calculate, perform this t-test for y, variable y. Okay, so we will take y, and then instead of x, y, we will put x is equal to null. Okay, now but we haven't calculated the mean of, yeah, so let's say mean in bracket y, right? So 39.9. Now we will rewrite the statement. So here we will take y, and then we will take x is equal to null, and then mu value we will put 39.9. Okay, and then press enter. Error invariance x is null. In addition, warning message, in mean default x argument is not numeric or logical. X is equal to null. What happened? Y comma x is equal to null. Error in variable x is null. In addition, warning message, the mean dot default x argument is not numeric. Just y comma x is equal to null. Mu is equal to 39.9. Yeah. Okay, let us x x is equal to null comma y mu is equal to 39.9, variance dot equal is equal to false. Okay, स्टार्टिंग पासून म्हणजे वाय तो वी हॅव ऑलरेडी डिफाईन्ड ना. बरं ठीक आहे. So x is equal to null, comma y, comma mu is equal to equal is equal to false. Okay. Hmm. I know. Just a moment. Maybe that it is taking by default the syntax that if it is one sample t-test, first variable has to be the defined variable, and the second variable has to be the null variable. I don't know, but this shouldn't be the case. P-value t dot test x comma y data 1 data 2. Okay, here the syntax is little different. Data 1 data 2. Okay, variance is equal to true. So it is two sample. Here also it is two sample. Okay, so they have defined one sample, two sample, one sample t-test. Okay, only one data. So instead of, okay, so let us try this way. Mm, Only we will take one variable y, mu is equal to 39.9. Hmm? Let us execute. Okay, so now it is giving the value. So in this case, okay, let us say execute this independently for x. Okay, so x, and then it was 42.9. 2.9. Okay, so individually it is not mandatory for you, even if you don't define null. For whichever sample you are performing this test, you should include that particular variable only. Like if you are performing it for y variable, or if you are performing it for x variable, you include only that particular variable, then define its average, and then define the variable values as false. Okay, yeah. Now for two sample t-test. Okay, now this is one more test. Okay, now in this case we have calculated, in the previous example, the mean we have calculated for x, that was 42.9, right? Now what we are doing is that we are putting some other value of mean. Mu is equal to 50. Okay, so whatever was the average, we are not taking that particular average, but we are giving some different value for the average. Okay, and then see what is the result of the test. So it gives the test result like this. So it is one sample t test only, data input is x. Okay, then t is the table value, that is nothing but minus 3.1511. Okay, degree of freedom is 9, that is 10 minus 1, that is 9. And then p value is 0.01172. Okay, this is the p value. So p value is less than 0.05. Yes, in this case it is less than 0.05. So when your p value is less than 0.05, we reject the null hypothesis and we accept the alternate one. Yeah, so alternate hypothesis is that the true mean is not equal to 50. Yeah, because true mean is 42.9, right? Yes. So, say for example, you are carrying out a research and then you have stated the population of some district. Say IT literacy of Pune district is 95%. Yes, this is your hypothesis. So, such type of hypothesis you can test using t-test, where you have given the value of the like literacy level, like 95%. So you can check whether the literacy is equal to 95% or not equal to 95%, like this. In this particular, see here we have defined alternative hypothesis, true mean is not equal to 50. So you can also state that true literacy percentage is not equal to 95, like that. Are you getting? So this is how you can define the hypothesis and then you can test it. Okay. So here in this case, confidence interval is 95. Okay. The interval level are 37.80 and 47.99. So lower level and higher level. Hello. 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 Yeah. Are you there? Yes. So this is how you can perform the t-test. Okay. We have seen two examples. Now two sample t-test. Okay. So it is called as Welch two sample t-test. Now in this case, what is the difference? In this case, you have two samples that are involved in the study. Like in this case, we have defined two sample as sample X and sample Y. Okay. So X here, the numeric vector, again the same example we will take. The only difference in the syntax is that we have taken X comma Y as the variable, and we are now not including any null, passing on any null value to the variable. Yes. Yeah. So mu again is equal to 50. This will remain same. Paired is equal to false and equal is equal to false. So this is the outcome, where it is a two sample t-test. What are the data parameters that we are passing? Both, like x and y, both sample. So two variables, numerical vector x and numeric vector y. Then it is giving the t value as minus 13.762. Degree of freedom is 17.703. Now since it is a paired test, okay, pair test, so the number of observations involved in the study are more. Okay, 10 for x, 10 for y. Okay, yeah, 20. But it not necessarily in whenever it is like two sample t test, it does not necessarily define your degree of freedom as n minus 1. So it takes some random value which is calculated by the software, but surely it is less than n minus 1. Okay, so in this case it is 17.70, so we can say it is 18. Like for example, if we round up, it is 18, like that. Okay, and so the p value is something at 6.838 e raised to minus 11. Okay, so that many 0.00000, like that, 68. You know the meaning of e raised to minus 11? Okay, so hmm So yeah, I'll tell you. So in this case, the alternate hypothesis is that the true difference in the mean is equal to 50. Okay, true difference in the mean is, sorry, it mean is not equal to 50. Okay, and 95% is the confidence interval, that is minus 4.18 and 10.18, and the sample estimate for x and y are 42.9 and mean of y is 39.9. Okay, so let me just check out here with another example. So it is a infinite value actually when we say e raised to minus in a1. Okay, it is giving the infinite value. Okay, so in this case, it is it is certainly not less than 0.05. Okay, so hence we fail to reject the null hypothesis and we accept the alternate, that is true difference in mean is not equal to 50 because it is 42.9. Okay, so the mean difference in mean is, let's say, 42.9 and mean of y is 39.9. So if you find out the difference between these two means, it is not certainly equal to 50, है ना? So in this case we reject the null hypothesis and we are accepting the alternate one, that is true difference in mean is not equal to 50. Okay, so that is how we interpret the value of the test. Okay, two sample t-test. And in case of paired t-test, the only difference is that you define paired is equal to true. Yes, paired is equal to true. For all the previous examples that we have seen, we have defined paired is equal to false. है ना? We have defined paired is equal to false. And for the paired, whenever you are including the two variables and you are carrying the paired test, that time you have to define paired is equal to true. Okay, and then you get the result like this. So paired t-test, it is data is x and y only. Okay, and then t value, degree of freedom, p value is there. So again it is 7.16 e raised to the power 08. And the alternative hypothesis, it states true difference in mean is not equal to 50. Okay, so whereas we have taken here the mean is 50, but we know that it is not 50. Okay, so true difference in the mean is not equal to 50, it is much lesser than that. So two difference in the mean of differences is 3. Okay, because 95% interval level we are getting is minus 3.7 and 9.7. So if you calculate the difference, we get the difference is 3. And here we are stating that it is not equal to 50. Okay. So alternate hypothesis is true, that the true difference in mean is not equal to 50, but it is 3 only. Yes. So that is how we interpret the test results. Okay. Hello. Yeah. So this is how we perform the t-test. Okay. You can execute these instructions, right? T-test. How do we perform t-test? Try different alternatives x, y, mu, paired, variance, like that, and then try to execute. Hmm? Next lecture, what we'll do is we will study some other techniques of hypothesis testing, like Kruskal Wallis test is there, and then some regression analysis Z test is there. Okay, so different types of parametric test that we will see. Okay, yes. Have you sent me the research proposal? Then when you are going to send me the research proposal?